In this video, I will explain how to use the Affine Cipher to encrypt and decrypt text. So here are the formulas that the Affine Cipher uses. To encrypt text, we use the formula AX plus B mod 26, where A and B are both between 0 and 25, and we get to choose A and B, and A must be coprime with 26, or in other words, the greatest common divisor between A and 26 must be 1. Or an even easier way to remember that is A cannot be even and A cannot be equal to 13. And lastly, X represents the characters A through Z mapped to the integers 0 through 25. And then to decrypt text using the Affine Cipher, we use this formula. A to the negative 1 multiplied by X minus B mod 26, where A to the negative 1 is the modular multiplicative inverse of A mod 26. And I'll explain what that is when we actually go through our decryption example. So first let's take a look at an example of how to encrypt text using the Affine Cipher. So let's say we have the plain text math, and we want to encrypt this text using the Affine Cipher. The first step is we need to convert each of the letters, so M, A, T, H, to their corresponding integers. So for example, M we can see corresponds to 12, so let's write 12. A corresponds to 0. T corresponds to 19, and H corresponds to 7. Next, we need to use this formula right here to encrypt the letters. So remember, we get to choose A and we get to choose B. They just have to be between 0 and 25, and remember, A has to be coprime with 26. So for example, let's choose A to be equal to 3, and we'll choose B to be equal to 7. So plugging these values into this formula, here's the formula that we can use. 3x plus 7 mod 26. So we're going to plug in this 12, this first value right here, in for x. So if we do that, we get 3 times 12, which is 36, plus 7, that's 43. So we have 43 mod 26. Now, when we say mod 26, that means we're going to do 43 divided by 26, and our answer is going to be whatever the remainder is. So if you do 43 divided by 26, you end up with a remainder of 17. So this remainder right here, this is what we're going to write as our answer right here. And then we repeat this process for each of the integers. So next we'll plug in a 0 for x right here. So we get 3 times 0, that's 0, plus 7, which is 7. So 7 mod 26. So when we do 7 divided by 26, 7 doesn't go into 26 at all, so the remainder is just going to be 7. And then next we'll move on to 19, so we'll plug in a 19 right here. 3 times 19 is 57, plus 7 is 64. So when we do 64 divided by 26, we end up with 2 with a remainder of 12. So this remainder right here is what we're going to write right here. And then lastly, we'll plug in a 7 for x. So we get 3 times 7 is 21, plus 7 is 28. So when we do 28 divided by 26, we end up with 1 with a remainder of 2. So the 2 is what we will write right here. All right, so the very last step to convert these values to the ciphertext is just to map these values back to their alphabetical characters. So 17 we can see corresponds to R, so we'll have R. 7 corresponds to H. 12 corresponds to M, and 2 corresponds to C. So the plaintext math encrypted using the Affine Cipher turns out to be RHMC. Alright, now let's say we're given the ciphertext RHMC and we want to decrypt this text using the Affine Cipher. In order to do that, we need to know the values for A and B that were used to actually encrypt the text in the first place. So let's say we know that A was 3 and B was 7. To decrypt this text, we need to use this formula up here. A to the negative 1 times x minus b mod 26, where A to the negative 1 is the modular multiplicative inverse of A mod 26. So what that means is if we have A to the negative 1, whatever this is, if we multiply that by A, and then we do mod 26, our result should be 1. So in other words, whatever this value is, when we divide it by 26, we want to have 1 as the remainder. So notice that if this quantity was equal to 27, if we did 27 divided by 26, we would get 1 with a remainder of 1, which is what we want. So what we really want is we want this expression right here to be equal to 27. Well, we know that A is equal to 3, so what number times 3 would be 27? Well, that would be 9. So A to the negative 1, this value must be 9. So that's what we can use in our formula up here. So we're going to do 9 times x minus b mod 26. And remember, x is alphabetical letters encoded using these integer values. So first, let's convert each of these characters to integer values. So the R, that corresponds to 17. H corresponds to 7. M corresponds to 12. And C corresponds to 2. All right, I'm going to clear a little space here. Okay, so now we'll plug these integers in for the x values in this decryption formula. So we said that a to the negative 1 is 9. So here's the formula we're going to use. 9 times x minus b, b we said was 7, mod 26. So when we plug in a 17 in for x right here, we get 17 minus 7, that's 10. 9 times 10 is 90. And when we do 90 divided by 26, that turns out to be 3 with a remainder of 12. So the remainder is what we'll write right here. And we'll just repeat this process for the last 3 integers. So we'll end up with 0, 19, and 7. So the last step to get our plain text is just to map these values back to their character values. So a 12, we can see that maps to M. 0, that maps to A. 19, that maps to T. And 7, that maps to H. So our plain text turns out to be math. So that is how you can encrypt and decrypt text using the Affine Cipher.